Okay, so I think it's the same exact as the prep, right?
Yeah, it's like the exact same thing.
Okay. Number one,
Sorry, it's loading.
so it would be 90%. We are 90% confident that this
Confident.
remains not
Yeah.
leaking.
Yeah.
Okay.
Okay, number 3.
Okay, so number 3, I put that no, the distribution of the mean of each sample is not normal since the sample size isn't large enough because they only have like, what,
20.
20 and 15.
Well, if it's greater than 30, then it is larger.
Yeah,
But is
Um,
it split up into 20, a group of 20 and a group of 15, or is it a group of 35?
I took it as a group of 35.
Yeah,
Okay, I didn't take that way. Okay, so it would be
but then it's still
yes.
no. No, it would still be no. Because,
Why?
um, one sec. I remember reading something that's like,
Wait, wait, it is separate groups, right? Because they want to see if males differed from females.
it would be the independent sample to sample T. So it would be independent, but I'm pretty
Wait,
sure.
are you on 3? Kimberly?
Yeah. But I'm just looking at it as like what one I would do, because then what one I would do would kind of base off if the normality would be.
Oh, I see, I see.
So what do they need to do in order to make it um, satisfied or whatever? The QQ plot and the sample size?
Yeah.
So wouldn't it be yes?
Research side 2.
Um, Wait, I think it would be two different things because look, create QQ plots of both random samples. So both random samples, and they want to see if males differ from females, so they're not gonna like clump them together. It's like two tests, you know?
Okay.
Am I wrong in my thinking there?
I just get confused with this one because it's two tests, but they both have a common element. So like when you have a common element,
That's what I'm wondering.
Oh,
you know what I mean?
yeah.
So if you consider them to be this like the same, then you'd have the sample size satisfied.
Yeah. I still put no, and I don't know why I put no.
I put yes, the distribution of mean of each sample is normal since the data have been determined to be normal. But what did you put, Carlton?
I put actually the distribution of mean of each sample is not normal since the sample size is not large enough because I was thinking it was two different samples, 20 females and 15 males is what I was looking at it.
So I don't know. I just think of it's the same study. I know
Yeah.
they're two different outlets of that study, but it's the same study, so I don't know. We can always
That makes
just move
sense.
on and go back to it.
Yeah. Sounds
Because
good.
what you're saying makes sense, but then like I
Yeah,
don't know
it
how to
does.
justify it. You know what I'm saying? Like,
Yeah.
Yeah.
okay, we could come back to that.
Okay.
Okay, of the four types of confidence intervals listed below, which is appropriate for this experiment? So I didn't know. I did the confidence intervals for different means using independent samples.
That's what I have.
Okay, good.
Yeah,
Yeah,
that's
I
what
have
I
that
have.
too.
Okay.
Okay. Okay, question 5. So it's just asking how to decrease your confidence interval. right?
Yeah.
Or margin of error, sorry.
Yeah.
So would it be you increase your sample size, right? Decrease your
Yep.
Okay,
Yeah.
so you obtain 90 instead of
Yep.
30.
Yeah.
So-
Okay, so this one I had a question on because I don't know. I'm confused about finding margin of error and all that without having SPSS.
Yeah, me too. I couldn't do this one.
I
Okay,
couldn't figure this
so
one out.
for this one, you use the formula x plus or minus z over the standard deviation over the square root of n.
Okay, hold on. I'm like making notes as we talk. So x plus or minus.
Okay, that's the
one?
one I got. Yeah, it's that one. But so this problem in particular, it only has the sample mean, and then standard deviation, and then the 95% confidence interval.
Yeah,
It
so the mean would be 1,000 milliliters. The z would be 1.96
Oh, because
because
of
it's
the
asking for
Z
95th.
star. Yeah.
And then the standard deviation says it's 2, and
Mhm.
then the n is 4.
How'd
She
you
selects
say
4 drive
4?
shafts. It says she randomly selects 4 drive shafts
Oh,
at the factory.
see, that's those kind of things that get me. Okay.
Yeah.
Hey Lauren, do you want to read me that formula one more time?
It's as it's hard to see, x plus or minus z with the standard deviation over the square root of n.
With the standard deviation? Yeah, you want to just hold it up. Times the standard deviation over rad n. Okay. And what is that formula called again? Just the finding the margin of error?
I think so.
Yeah.
The confidence interval or margin?
Yeah.
What are we doing? No, I don't think it's the margin of error. It's a confidence interval.
Yeah.
Okay. What did you guys get?
I got for the lower number I got 998.04.
Yep.
Okay. And I'm doing the upper right now.
Okay, wait, so how do you find, hold on.
So wouldn't actually the margin of error be the upper bound minus the lower bound divided by 2?
Okay, yeah, that's what she said.
Yeah.
But I mean, I don't know if that applies to a different type of question because I was looking back on my notes, and for this week, they do a different equation to find the margin of error. So,
Yeah, because she, in her notes or in her video she just did, that's what she said too, is upper minus lower divided by 2.
okay, then let's just stick with that.
Okay. So I got 1.96.
1,001.96?
No, that's what I got for the upper. For the margin of error.
Oh, sorry. I was just looking at my, yeah. Okay, so, let me complete it really fast. You're probably right, but I'm just kidding.
So, hey Kendall.
Oh no, I don't know if I'm right.
Okay, yeah. Hey Kendall. So on this, like I have this so far, if you can see it. It's like 1,000 plus or minus z-score rad 2 over rad 4.
I'll show you my formula.
Like how do you know what the z-score is for
that? Do you see that? Is it blurry?
Okay, wait. This is for number 6. Like you have to input both of those.
Yeah. So that z star. Yeah. That's see how it's like one's lower and one's upper.
Okay. Wait. Hold on.
And so that z star is that. So like the 95 is the
Oh,
1.96,
okay, hold on.
that kind of thing. So we would just do that formula.
Okay, 95 equals 1.96, and then 90.
Yeah. 90 equals 1.615.
Okay, sweet, thank you.
Uh-huh.
Okay, so it would be
And then lower.
okay. So then, did you get? It would be 1,000 for 95%. So it's a z-score of 1.96. So it'd be 1.96 times 2 over rad 4, which is just 2, which is 1, right?
Mm-hmm.
So it would just be 1,000 plus or minus 1.96.
Yeah. So plus on one side and minus on the other. Yeah. The
So,
upper and the lower.
okay, what would it be for just the margin of error? Oh, 1.96.
You would take
Yeah.
you would take those the upper and then the lower that you find, and then you divide it by 2. Did you get 1.96, Lauren?
Yep.
Okay. I hope we're doing that right.
I think we are.
Okay.
So for the lower, did you get 998.04?
Yep.
Yep.
Okay. And then obviously 1,000, 1.96. And then to find both of them, you subtract. Is that what you do?
Huh?
Yeah, you subtract the upper from the lower and then divide by 2.
So did you get 1.96?
Oh.
Yeah.
Uh-oh. Okay. Sweet. One second, I have to plug in my computer, guys.
Oh wait.
Okay, are we good to go?
Yeah.
I'm just trying to figure this. So, what did you get for just the margin of error? Just
We got 1.96.
1.96. Then the lower was 998.04,
Yep.
and the upper was 1001.96.
Yep.
Okay.
Yeah. I put a 0 on both of those just to make it 3 decimals, but I don't know if that matters.
Oh, good idea.
Okay.
Yeah.
Okay.
So the next one, you just do that n formula, right? Because you're trying to find the sample size, right? Okay.
So n
Oh.
equals z times standard deviation over m squared.
Yeah.
Over n
So I
or
got
n squared?
m. So the margin of error is m.
Oh, okay.
Sorry, my handwriting is like really messy.
Yeah, that's what mine is
Equals
too.
times,
You got 38.416? That's what I got too.
Okay, sweet. Okay, wait. So I'm sorry, you got the 38416?
Yeah. I did.
Sweet.
Hold on, you guys are a lot faster than me.
So what was that? N equals 2 times the standard deviation divided by what?
That one divided by m, which is the margin of error. So
Oh.
that red mark is the z. Sorry. And then it's the times the standard deviation divided by the margin of error squared.
Wait, I got a
Wait.
huge number.
Wait. What equation was that for, Kendall?
That n one, that's for the how to find n.
Wait, are you pointing at the right thing?
Yeah. That one.
Oh, okay, that's
Sorry.
Yeah, that's it.
I
Yeah,
always
n
point
equals
that.
z times standard deviation over m squared.
I got a huge number, guys.
You're probably
Yeah, what'd you get?
times it by the standard deviation.
38,416.
Yep, that's right.
Oh, what? Okay, and so that's to find the sample size.
Okay. Did everyone get 9?
Yeah.
I haven't actually computed it completely.
You have what?
I haven't completely done it yet. Okay.
Carl, did you need help with 9?
38,416.
Yep.
38,416.
Yep.
Yep.
Okay, number 10.
Okay, so that one, I just got the last one.
Yeah.
Yeah.
Will you guys explain that to me? I'm so confused with these ones.
Yeah. So, the null hypothesis is saying that the mean is equal to 1,250, and then the second sentence is a tenant group links that apartment or thinks that the apartments are smaller than advertised. So the alternative hypothesis is saying that they think it's less than that 1,250, and that would be the
Okay, that makes
alternative.
Okay. Cool.
Are we good?
Yep.
Okay.
Okay. Number 11, in a statistical test of hypotheses, we say we reject the null hypothesis when the level of significance A is...
The p-value is less than A.
Yep.
Yeah, that's what you values less than that.
Sweet. Okay. Number 12.
Did you guys get B for 11? Sorry.
Yeah.
Mhm, yeah.
Okay.
Who did that? Not me. Oh yeah, Mom said you have to do that.
I didn't do anything. Okay, so for 12. So it's yes because they want to find 4 sample means, right?
Yep.
So, but it's only, but it's a sample size of 15 from 4. So, no, they don't have enough data then?
No, they do.
But it's a,
So it's asking for the ANOVA testing. It just needs to make sure that the graph is good with no outliers. It's normally distributed, and then the variances are equal. And it says the variances are nearly equal, and that it's a bell-shaped curve with no outliers. So yes, it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
Oh, okay.
Does that make sense?
Yeah.
Yeah.
Okay. Cool. Oh, yeah. Okay, 13.
Okay, so I always forget these type 1, type 2 errors, but I just like looked it up and I'll probably just like write it on the card for the test. But
Yeah.
I said that it's
Well, for
committed a
this
type
one,
1 error.
yeah, that's what I did too.
Yeah.
Because she said she rejects the null hypothesis. So
Okay.
when you reject the null, it's always a type 1. And when you
Okay.
fail to reject, it's always a type 2.
Okay.
Sweet. Number 14. Carlton, are you good?
What's that?
Are you good?
Yeah, I'm good.
Okay, number 14.
Hello, listeners.
Oh yeah.
It's reduced, right? By reducing the probability of committing a type 1 error, we also reduce the probability of.
No.
Wait, I feel like that's wrong. You
No.
increase.
Increase the
Yeah,
probability of
Yeah.
increase it. Yeah.
that'd be A.
Yeah, that's what I think.
Okay. Number 15.
Okay.
I don't know how you would find this one. Would you just try to find the p-value and then
Yeah, right?
Yeah. So, well,
what's the formula?
So what I did, I don't know if this is straight, but I found like the z-score formula. So I did the 1.53 minus the 1.5 divided by the standard deviation of 0.17 over the square root of 100.
Okay.
And I got a z-score of 1.764. And I plugged that in and just did the greater side and found the p-value and compared it to A.
Oh, okay. That makes
What
sense.
did you get for that p-value?
0.0388.
So it would be less than, so you reject. So it'd be
Yes.
D.
Yeah.
Okay. And then,
Reject.
okay, so that z-score, it's bar x, right? Minus sample, or no? Minus.
Yep.
Or wait, no, mean minus sample over standard deviation.
Mean minus the sample, the U.
Wait, u is the mean.
Yeah. So you do the sample mean minus the actual mean divided by the standard deviation over the square root of n. Does that make sense?
Yeah.
So I got that A was the answer.
You got reject the null. That's the alternative. So it'd be
it's
D.
not. Yeah. Okay, and then these ones, I have a hard time, like number 16. I put the very last one sample t-test.
No, it won't be one sample t.
So how can you
because you're
tell those?
So she explains it super well in the video. Like
Okay.
that's how I learned it, basically, because I had no idea what it was. But so since it's male and female, she gives examples of like. So I put independent sample T, in T-test because it's male and female. But one
Okay.
of her examples in her thing is male versus female.
Oh, cool.
So
I'll go back and watch that. Is that in her
yeah,
review video?
yeah,
Okay.
it like goes over this
Sweet.
stuff really well. So I got
So
independent sample.
awesome. That's what I put too.
Okay.
Yeah, I got it. Yeah.
Okay, number 17. Oh yeah.
This one's a little bit tricky because they are male and female, but they're also brother and sister.
I think it's dependent, right? The
So,
sister's academic achievement depends on some
yeah,
degree of her
they're
brother's
dependent.
academic. Mhm.
Wait, which one did you get?
Wait.
Or wait, is it D?
I
Yeah.
put D.
Yeah. Just
I
kidding.
put D as well.
Yeah.
Yeah, yeah.
Okay.
Yes, finally SPSS problems. I like these now.
So this one I just kind of guessed and said that confidence interval for you when the standard deviation is unknown.
My SPS is still loading.
Yeah, I don't get this one.
I don't know how you know between unknown and known.
I don't know. Yeah, I don't get it either.
Yeah. Wait, did you put A, Warren? And Kendall?
Yeah.
Yeah.
Yeah,
I feel like that's right because
but I'm not too sure.
Yeah, I don't know that one at all.
That might be a question we could ask her, but
okay,
we'll
so
just go ahead. Go on.
yeah. Sweet. 19, which is it? Okay, so for the student margin of error, did you get 0.967?
1 sec. It's loading. Yeah, 0.967.
Okay, what'd you get again?
0.967.
0.967.
Where'd you guys get that?
You just go to analyze and one sample t-test.
Oh.
Oh, I did analyze descriptive statistic and explore.
Okay, so
Wait, for the lower and the upper, then Kendall, did you get 11.168 and 15.217?
Yeah.
Okay.
Yep.
so I have those. Where do you find? Okay, Kendall, when you did the explore, where does it say the margin of error?
Oh, no, it says the STD error.
Oh, that's the answer?
Yeah.
Yeah, I'm
Zero
pretty
point
sure.
nine
I
six
mean, we could
seven.
always figure it out, because it just,
Well,
the
that's
upper and
what I just
lower.
did, and I didn't get the same thing. So
You didn't?
doing
Oh,
the
shoot.
15 minus 11 divided by 2,
Yeah.
I didn't get the same
Oh,
thing.
yeah, because that's a big error. I actually think we should just stick with the 15 minus 11 divided by 2.
Okay. So let me know what you guys get when you do that then.
It's gonna be like 2 something, right?
I got 2.
2.025.
Here, I'll put,
That's what I got.
yeah.
So we're
That's what I
sticking
got
with
too.
yeah, 2.205. So we're doing that.
Sure.
Wait, what did you get, Lauren?
2.025.
2.025, right?
Yeah.
Okay, yeah.
Oh, how's it going?
Yeah, we should just do that, and then if we get it wrong, then we'll just do the other one.
Okay.
That's what, like, she explains in the video, so that's kind of what I'm thinking.
Okay.
Just to go with.
So that number, just to go over, number 20 was 11.168,
Yeah.
Yeah.
and then 12 or 21 was 15.217.
Yeah.
Okay.
Okay, I'm so bad at this on that. Get like you guys on this too. On this one, did you guys get B? Or using or sorry, C.
I did see.
Yeah, I think
But
that was
again, this is one of those ones I don't understand completely.
Yeah.
Yeah, I don't understand a lot of it.
Okay, and for this one, are you guys just doing the same thing you did before on SPSS?
What's it asking for? Yes.
Oh, okay, so it's the dependent, like, so you have to create the 2 groups, right?
Oh, this was like, okay. What we did?
So it's the automatic recode one.
Okay, and which one do you, so, transform.
Wait, let
Did
me
you
see.
the automatic recode and like the independent sample t-test?
It's an independent sample T, okay. Is it,
What was that? Sorry, it's cutting off.
I was just saying, after you did the automatic recode, you went to analyze, compare means, independent sample t-test, and then you put the price in the test variable
Yeah, independent.
and the code in the grouping variable, and define groups. So what did you get for the lower bound?
1 second. I have to do it real quick.
okay, I got a negative number. What?
I got negative 79, no, I'm so sorry, negative 769.741.
But I thought you always take the bottom row. So it's negative
Oh,
423 for 1.
yes, sorry.
Wait, what would you guys group it in?
Just group
Do
one
you
and group
group
two.
by the? I know, but by like the H.
The city.
I grouped it by the city.
In what variable?
Yeah, the city
city,
because they're
okay.
comparing coasts. And then for upper, did you guys get 5,417.256?
Yep. Carlton, are you with us? Haven't heard you in a while.
Yeah. I'm here.
Okay.
I'm just trying to wait on this to come up.
Do you need like caught up on anything?
I was just running this deal.
Okay, question.
on
What
this
would you put in
problem.
test variables? Like what data would you put?
The
Price.
price.
Which one?
The
The
price.
price.
Oh, the price. Okay. Sorry. I think he's going in and out.
No, you're fine.
Okay, so lower I got negative 423.158.
Yep.
And then upper I got 5,417.
Do you guys want me to vote out of mine? Are you guys on the next one?
I'm just pulling up the SPSS right now.
Okay, cool.
Yeah, I'm pulling it up too. So for this one, once you do a matched paired team, so a paired
Well, I think
difficulty
there's
test.
3 groups, so
Yeah,
it
there's
was
3.
ANOVA.
Oh, there is 3?
Mm-hmm, yeah.
Oh, there is. Okay. So it'd be a
And
Nova, right?
Yeah.
I think I did something different on that 23, 24. So I transform automatic recode.
Yeah.
Okay.
Yeah.
And then I put the seller in the variable.
The city. I think
The
it's the
city.
city that's the variable.
Okay. That's nice. That's coming up with this crazy amount of
Yeah.
stuff.
That will mix things up for sure.
And then I just analyze Descriptive, statistics, and explore.
So you could do independent.
So go to compare means,
Oh,
and then
you go
independent
to
sample T.
independent T.
I just want to throw up on my sock. That's so gross.
Wait, what did you just say?
I was cleaning up my nephew's puke before this. I just found some throw up on me. So 1 second.
Do either of you guys have kids?
No.
Thank heavens for that. One of those sweet moments. Lauren, so how did you find the test statistic for this next question?
So you would basically, you would do the analyze, compare means, and then one-way ANOVA.
And then it's just the rat bone density, right, in the dependent list. Oh wait,
Yeah.
I need to. And
Well,
so
I think we have to do the automatic recode first.
yeah, I think it's right.
Oh yeah, you do have to do the automatic. Sorry.
So you put the treatment
Yeah.
as the new code.
Okay. And then T for this one's F, right?
Yes.
So I got 7.978.
7.978. Yep.
This one's gonna be a ANOVA hypothesis.
And for the P, I got 0.002.
So how did you figure that out?
It's right on the.
So
Okay,
The p-value is just the sig next to
oh,
the f.
oh, 0.002 you said?
Yep.
So the p-value is less than it, so we reject the null hypothesis. Null hypothesis is that
So there is sufficient evidence to conclude that the bone density of at least one group is different.
yeah, that's what I got. So it's.
wait, there is
seven
sufficient
plus.
evidence?
There is sufficient as evidence.
Yeah. Because we reject null.
Yeah.
Sweet.
So is that C for you guys?
Yeah.
A little bit high. Y'all go ahead.
Okay.
Okay, so this one would be a one sample z-test? Nah.
No, z-test is only if the standard deviation is known.
Oh, okay. So, I have no idea.
I said dependent because they're comparing the 14 to the 90, and they need to be grouped together. Or whatever.
But the 14 doesn't depend on the 90.
But they're comparing each other. Wait, yeah, they do. Because they want to, does that make, like, they want to check the same airline to make sure that there actually is a difference between that specific flight from this day to that day.
Okay.
Yeah.
But Carlton, where were you? Do we need to stop for a second?
Yeah, I'm still back here on this bone density
Okay.
thing. I'm kind of confused. I went to the automatic recode and I put
Okay.
in the rat bone density. Is that the correct into the variable?
What did I do? I did the treatment because there's like 4 different types of treatments, and you want to or 3, and you want to differentiate between the 3. So you need to do
Okay.
the automatic recode for the treatment, and then.
And then the bone density's got your data, your numbers for that, right? Okay.
Yep.
What really helped me with the SPSS stuff is I went through each lesson and wrote out what I have to do in SPSS for each one. Does that make sense?
Yeah, I'm gonna do that.
You did? Oh, okay. That's really smart.
Mm-hmm.
You did that for the direct cost ones, or the Nova one?
I did all of them. So I like wrote out what I needed to do for each one.
Oh, that's smart. Okay. I'm gonna do that. How did you guys do on the last exam?
I did good.
I did.
I did good.
I did pretty good.
I did good, and I didn't have SPSS downloaded, so I automatically missed 3 of them. Like, great. But this time I'm prepared more, so hopefully I'll do better.
Yay!
So then the test statistic is the F, right?
Yep.
Yeah.
7.978.
Yep.
Yep. So we did
And then the
dependent on
p-value
this
is
one, right?
that number right
0.002.
Yep.
So was it the next one was A, the evidence to conclude that they're all different? There's all the groups are different.
No. It's sufficient evidence, but it's just at least one of the groups is different. It's D, I think. Because there's no way we can know if all of the students are in the group are different, but we know at least one is.
Okay, let's see that.
29. Okay. Oh yeah, we already said dependent. What did you guys get for the T-test?
Hold on, see,
Did you do 14 minus 90 days?
I did 90 minus 14 days. I don't know if there's a
That is
difference.
90 minus 14.
Yeah.
I
Wait,
don't know, because in the problem, one sec.
Is that a one sample t-test?
It's the
No, it'd
dependent
be
sample
a.
test.
Then, okay.
Keeps freezing.
so it's 90 minus 14.
Did you do 90
I
minus
wonder
14? Because it says in the thing, it says.
Oh, I did
perform
14 minus
hypothesis
90.
test to determine.
It's 14 minus
You
90.
did 14
Yeah.
minus 90?
Yeah,
Okay.
sorry, that's what I did. I just told you wrong.
Okay.
Okay, and then it would be for the dependent. Is that just the? Oh my gosh, I don't even know. How would you? Where would you go from there after you compute variables?
Analyze,
Mhm.
compare means, and then the
Mhm.
paired samples t-test.
Okay. Okay, and then
And then I just put the variable 1 14 days and the variable 2 90 days and pressed OK.
there's supposed to be an F value, isn't there?
And F,
Yeah, because F is the test statistic, right?
that's just for ANOVA.
Oh, okay. So the test statistic here is what? Is it the T? Oh, 1.685?
Yeah.
Yes.
Is that what you got, Kendall?
Pearl, how are you doing?
I'm slow.
So what'd you guys get for the T for question 30?
1.685.
Yep. Okay, I got that too.
Okay, and the p-value, is that your sig two-tailed?
Yep.
Yeah.
So 0.096.
Okay, I have a question. Yeah. For the P, when do you divide it by 2?
You divide it
Good question.
you divide by 2 whenever the alternative hypothesis is saying that it's either greater than or less than.
Okay.
And this one, it
That
doesn't.
makes sense.
Yeah, this one's just saying they're expecting it to be different. They want to know, so you don't write it.
Okay,
Yeah.
sweet.
Because whenever I think of that p-value, I think of the graph, and it keeps going. And either both of them are going to be highlighted, or just one of them, depending on what the question is saying.
Mhm.
Where are you,
Okay.
Carlton?
I've transformed it, the compute variable. Now I'm just going to analyze statistics, right? And explore.
No. Go to compare means,
Okay.
and then go to paired samples t-test.
Okay. Yeah, that makes sense.
Maybe that will give you the same thing. I don't know. Kendall, did you sauce a different way?
What did you guys do for it?
I went to analyze
So I
descriptive
did,
or sorry.
yeah.
What did you do?
So I did, transform and then commute variable. And then I did that whole thing. And then I did analyze, compare means, and then one sample t.
Oh. So I guess you could do it that way too. I went to the paired sample t-test, but it gave me the same answer. So
So the statistic would be 1.685.
what was that?
Would that be the statistic would be 1.685?
Yep.
Hello? 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 And the p-value would be 0.000?
No.
No?
The
I got
p-values,
I have like
was
0.96?
Yep.
Yeah.
We got the wrong one.
I got 0.096.
0.096.
Yeah, 0.096.
Okay, sweet. And then number 32, you're just comparing that to the 0.10.
So that's B, right? Please let me get that right.
Yeah, I got B.
Yep.
Okay, I'm gonna submit this. Okay, looks like we missed 3 of them.
Which ones?
Hello?
Number 3.
Yeah.
Okay, wait, what did you guys put for number 3?
Let's do this group thing.
I put yes. The distribution
Okay.
of the new sample is normal since the data have been determined to be normal.
Okay, wait, I put no because the sample size is not large enough. We were gonna come back to that, I forgot. So it's not the
Okay.
first one.
So I'll try number C, and then we'll see where that was from. But what else did we miss?
Okay, so we also missed, the margin of error. Oh, with the 95% confidence, number 6. So, what?
Oh, so it must be that one.
What was that number again?
I don't know.
I don't remember.
I can pull it back up. I need to practice anyway. Okay, and then we missed number 19. So number 19, that is that number that was there. It's not the upper minus lower divided, or whatever, divided by 2. It's just that number, which was like 0.0 whatever.
Okay. So let's go back to number, what was that last one?
19.
No, the one before that. Let's do that one first.
Number 6?
6.
Okay, number 6.
Wait, what was the other one we got wrong?
So 3, 6, and 19.
Oh my gosh. I have no idea what we missed on number 6 then.
Yeah.
Because we don't have any SPSS.
Sorry, guys. What was the other number? It keeps cutting out for me.
Oh, you're fine. 3, 6, and 19. times over rad. This is Z squared.
So I'm wondering if we need to number.
Oh, okay, wait, I think we did the math. Wait, did we Z score times Z score times. This is what you guys said. Z score times standard deviation over rad. N, right?
So what number are you on?
Number 6, right?
Yeah. Okay. Wait.
So rad 2 or 2 over rad 2 is 1. And then the Z score is 1.96. How is it not 1.96?
No, I think those are right. We got the upper and lower bound right. But I think we have to use this random equation that was different from
Oh, is it the Z? Wait, no. That one?
Because I just Googled how to find the margin of error, and it's Z-score times standard deviation over rad n.
Yeah, that's what. There's another formula for that too. Ugh. So many.
Well, because I've got like margin of error equals 2 times the standard deviation divided by the square root of n. This is what I got wrote down in my note.
Okay, wait. What did you
No,
have written down?
1.96 again.
Yeah. Carlton, what did you say you had written down?
I
2.
have wrote down 2 times standard deviation divided by the square root of n.
Okay,
so the 2 number in that
okay,
equation.
2.
The 2 number in that equation is equal to the Z-score though. So depending on the question, that 2 is going to change. And since we're doing the 95th, it would be 1.96.
But that's what we put. Right?
One second. I know that there's an equation I have written down for this.
Do you think it's 2? Carlton, where did you get that thing?
No, I just have it wrote in my notes that that's the margin of error formula.
Do you guys care if I could call my mom and ask her? Hey, Dad, is your mom there? Okay. Will you ever call me when she has anything? I just need help with this stats. I just need help with this bio stats. Okay, I'll call her.
Oh!
What?
Oh,
Nothing. Okay, I see what you're saying, Carlton.
Everybody there?
2 divided
Yeah.
by 4 equals times 1.96. Yeah, I'm totally lost on number 6 then. Because even with that equation, I still get 1.96.
Okay, did you guys figure that out or no? I did not.
No.
No.
I'm trying to get a hold of my mom, see if she has it written down.
What was the other question that we had?
3, 6, and 19.
Okay, I'm gonna go to 19 and figure that one out.
Yeah, I was looking.
Hey,
Hey,
did you
stupid compliments.
do the
Okay, so I think 19 is 0.967.
Me too.
Okay.
That's what I got.
Okay. We should email the teacher about her telling us the upper and lower bound minus or divided by 2. Because on this case, it doesn't work. And the formula for margin of error.
did you guys get number 19?
Yes.
Okay, what did you get?
What was it 0.967?
Yeah.
Okay.
Okay. I do not have a lot of time, so I think that, like, do you just want to submit what we have and then I can email her? Or, like, even I can do that and you guys can stay on. Like,
So your mom, she didn't have it?
no, she didn't have it.
Like her group got it wrong too?
She hasn't even met with her group. They meet tomorrow.
Oh.
Yeah.
Okay. What's there?
Let's see. Give me 1 minute.
Lauren, do you want to read me the rest of the answers?
For what?
Do you want to go over the rest of the answers with me?
Oh, yeah, sure.
Okay, 3 is. What did you put for 3? C?
Yeah. Yes, the distribution of means of each sample is normal since the data have been determined to be normal.
2, 4, what did you put?
C, confidence interval for the differences of mean using independent samples. 5 was obtain balances of 90 bank customers rather than 30. 6, we're confused on. 7, 998.040.
198.04.
Yep.
1000.
Number 8, 1001.960. Number 9, 38,416. Number 10, the null is equal to 125. The alternative is less than 1250. 1,250.
We reject if it's less. Okay.
What?
11 is B.
D.
Oh, wait. Wait, reject the null hypothesis. Alpha. Wait, is p value is less than alpha, right?
Yes. P-value is less than alpha.
Awesome.
12 is yes, this is enough. Oh, it is enough that the data for each apartment building are bell-shaped with no other outliers and the sample variances are negligible. 13, committed type 1. 14, by reducing the probability of committing in type 1, we increase the probability of committing type 2.
Okay.
15 is reject the null. 16 is independent sample t-test. 17 is dependent sampling. If you select a brother so as to compare his academic achievements to his sister, you must include the sister in your study. 18, confidence interval for U is whatever that symbol is unknown.
Is unknown.
Yeah, unknown.
19.0 or 0.967.
Yep.
Hey guys,
Yeah.
I got a different number for 6,
Oh, sweet.
but I don't know if it's right.
What?
Oh wait, mine. I didn't divide by 2. Yeah, never mind.
You want me to keep going, Thailand?
Yeah, please.
Okay, what number are we on?
20.
20, 11.168, 21, 15.217.
Wait, what is 2168?
Wait, number 20
Yeah.
is 11.168.
Oh. Alright, awesome.
21 is 15.217. 22 is confidence interval for the differences of means using independent samples. 23 is negative 423.158.
Do you want it? Yeah, yeah.
24 is 5,417.256. 25 is ANOVA. 26 is 7.978. 27 is 0.002. 28 is there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups. 29 is dependent samples test. 30 is 1.685. 31 is 0.096. 32, there is sufficient evidence to conclude that there is a difference in the mean cost of 30 days in advance compared to 90 days.
Perfect. And for number 6, we never figured it out.
No.
I'm looking it up right now in the book.
Would you guys hate me if I just posted what we have so far, which is like an hour worth of video, and
We can do that.
because I have to go.
Yeah, that's fine.
Let's see. I'm gonna submit. So I used Carl's thing, the 2 times standard deviation over rad sample size, and I got 2. And so let's see if that is the answer. Nope.
That wasn't right.
No.
Wait, what wasn't right?
It wasn't 2 times standard deviation over rad sample size.
Did we get number 3 right?
Number what?
Yes. Yes, we did.
So 3C.
Or whatever Lauren had, yeah.
Okay, and then what was the other one that we got wrong? 19.
19.
Yeah, we got that right.
It's 0.967.
Mhm.
Okay.
Okay, I'm just gonna submit it. Well, Kendall, are you still looking it up?
Yeah, but it keeps giving me the same formula, so I don't know what to do.
Like, I don't either.
I'm just gonna submit it.
Okay.
I'm just gonna submit. I've been up for a long time, so
No, I'm tired too.
I know.
Alright, I'll post it with who participated, and then I could also like post it on there. I'll be like, hey, like we couldn't find this out. Like, please help.
Okay.
Is that cool with everybody?
Wait, what'd you get for number 19?
0. Oh, I got number 19 wrong.
Wait, what did you get for 19? Why did I freaking exit already?
0.967.
0.967.
I thought I got that right.
You got it right?
I thought I did. I just like glanced through it really quick. I thought I did.
yeah, I didn't get it right either.
I hate seeing that 93.33%. I'm not gonna lie.
I got a 91 point something, and I'm like, how do I look in and see what I got on this?
Go to are you at the lesson 15 group meeting quiz?
Uh-huh.
So go to that little arrow to the right of that headline,
View submissions.
and yeah.
So, 19. Oh, yeah, I missed that point. 967. So we're just
Okay.
missing the margin of error.
And 22. I missed
Yeah.
22 also.
Oh.
Okay, wait, I didn't miss 22.
What
Confidence
would you
interval
for
for the different. So it's confidence interval for the different difference of means.
That's the one I got wrong. Dang it.
Using independent, yeah.
Samples. Yeah, using independent samples.
Okay.
So, yeah, I guess yeah.
Well, do you guys want to meet? Oh, sorry. Do you guys want to meet again before we take the exam?
I don't know if I'm
I
gonna
mean-
have time.
I was planning on taking it tomorrow morning,
Oh, no, no, no.
but I can email her and ask her about number 6 and 19, and then let you guys know what she says about them.
Okay. That sounds good.
Okay.
Okay. Bye,
Awesome.
guys.
I'll see you. Good luck on the test.
Yeah, you
Good luck,
too.
everybody. We're so done with this. We're gonna do great.
Yes.
All right, see you guys.
Okay,
All right.
bye.
All right.